Hello, welcome back. In this segment, I want to spend a few minutes explaining the connection between discrete logarithm and ElGamal digital signature more explicitly. In the previous segment, we saw the construction how ElGamal digital signature actually works. What is not so explicitly discussed was, is it really equivalent to discrete logarithm problem? So I want to take in two steps. First step is that we know that g power m has to be equal to y power r times r power s for m r comma s to be considered as a valid signature for a message m, right? So the question now is, can an attacker who doesn't have private key X, right? Remember, private key X is needed here to sign the message. S is made of X. But the question is, can you construct message and r comma s without having private value X? That's the question. Remember, this is the goal of verification, right? The verification is going to check whether is g power m equal to y power r times r power s. How is y constructed? G power x. X is private, y is public. So let's assume I'm an attacker and I want to sign a message m, arbitrary message, but I don't have a private key x. So what I can do in this case is I'll go ahead and generate a random number r, right? So now the next thing I need to do is I need to generate an s, right? I know g power m. Of course, g is public, m is what I have chosen. You can rewrite it as like this, right? Equal to r power s. Okay, this is some number. Okay, we don't care what it is. Let's call this number to be z is equal to r power s. Okay, we know r, so this is exactly like discrete logarithm structure, right? Given z, given r, find s. So if an attacker starts with selecting a message m and generate a random number r, the problem of finding s appears to be equivalent to solving a discrete logarithm problem. That's the first observation. Okay, now let's take the other one. What if I first select s, then I go ahead and select an r, okay, for a given m. Okay, now let me rewrite that part. Suppose I select m and I select some random s. Remember, s depends on x, but we don't know x. But I just randomly select yes. Okay. So the question now is, how can I generate an R, right? So this problem is not so clear because you see here there's an R up here. This is not necessarily equivalent to solving discrete logarithm problem, but at this point it's not clear whether there is a polynomial time algorithm that can find R given m yes. Okay. So that is, this part is not equivalent to discrete logarithm problem part as far as we know. Okay. Now, one more option is, why not given m, the third option is now, given m, why not we simultaneously find r and s, right? That we don't know how to select r and s simultaneously to satisfy this equation. So to sum up, one portion of this equation appears to be equivalent to solving discrete logarithm problem. The other two options that I talked about are not necessarily clear whether it's equivalent to discrete logarithm problem. Okay, that's the main point of this session. Thank you very much.